Welcome to all of you on the channel Maths with Munir. I hope that you all are doing great and watching my videos. The topic that we are going to learn today is very important, not just because of its for the examination point of view, but also due to the application in our daily life. So yes, today we are going to talk about derivative of a function. So I am assuming that you have watched all my videos related to the topic functions, and now you have a better understanding of what are functions and why we are using them, and obviously how we can have an idea whether an equation is a function or not. So if you are new to my channel, I would encourage you to please go through the playlist of functions and their graph. Watch all those videos over there, because functions are the prerequisite of a derivative. Then you can come back to this video and then you can learn about derivative. So today we would not only commute how to find the derivative of a function, but we will also look upon the basic features of derivative as well. So let's begin with a very simple question, that what are derivatives and why and how we use them. Derivative is rate of change of one thing with respect to rate of change of another, rate of change of one variable with respect to rate of change of another variable. It's a very basic simple definition that we can say about the derivative of a function. Now once we are studying mathematics, we really have to be careful about the terminologies that we are using in math, because it would be more better if we say that rate of change of dependent variable with respect to rate of change of independent variable. And let me tell you one quick thing over here, that once we say that rate of change, it means that we are talking about slope. And how do we calculate slope and how slope defines on a curve? We will come back to this point as well. So let's start with rate of change of one variable, independent rate of change of dependent variable with respect to rate of change of independent variable. So let's have a very close look on this thing. I'm going to give you a quick example from which we will understand the basic concept of dependent and independent variable, and that is how you will be able to know about derivative as well. Okay, so over here we can see that the example that I have taken over here is y is equals to x plus 3. So I can say that y is a function of x. Once y is a function of x, it means that the value of y are depending upon the values of x. Over here in this case, we are free to take whatever values of x we like from the set of real number. We know that on a real line on right hand side we have positive number, and here we have negative number. So from this real line we can take any values of x that we like. So all the values of y are depending upon the values of x. So it means that we will say y over here is dependent variable and x over here is independent variable, because for x we can take whatever value we like. Alright, so that was a quick concept of dependent and independent variable. Now let's come back to the point that rate of change of dependent variable with respect to rate of change. So rate of change means that we are talking about slope, and we know that from the calculus the basic formula for slope is rise over run. Rise over run. Rise means that how much change that we have in on y-axis. So it would be y2 minus y1 over run means that x2 minus x1. I will explain this point as well, that how it is y2 minus y1 over x2 minus x1. So for the better understanding, let's take a graph, let's take a curve on a graph paper. Okay, so we have a plane, xy plane. This is our x-axis, and here we have y-axis. So I'm taking this curve on my xy plane. Okay, all right. Now we know that the slope is always being defined between the 2 points. So I am going to consider 2 points on this curve. Let's say that the point I am taking over here is A, and the point that I am taking over here is point B. And we also know that whenever we want to write the coordinates of a point, of any point on xy plane, they have always been written as in terms of a into x comma y. I mean, the first value will always represent that how much distance it have from the x-axis or from the origin, and the second value will always represent y, that how much distance it have from the origin to y-axis as well. All right, so I am taking the point over here. Let's say that the distance over here is basically x1. So let's say it, okay, x1, and over here this is your y1. This is y1. Okay, so the coordinates of point A will be written as x1 comma y1. Okay, now once this point is moving from point A to point B, you can see that we are moving from the left hand side to the right hand side. Once we are moving from left hand side to the right hand side, it means that we are going in this direction. So the value of this point B will be over here. Now it will not be x1, it would be x2. Okay, so similarly over here it is y2. So the coordinates of point B are x2 comma y2. So how much, so like I said, the slope is basically rise over run. How much rise do we have on y-axis? It means that how much change that we have. Once we say that how much change we have, it means that we are talking about from final position to the initial position. The initial position was over here y1. So the change over here was y2 minus y1. Okay, if the variables are making you confused, let's take some real number for the sake of our own simplicity. That I am saying that, okay, this is point O, which is origin. Let's say that distance from O to y1 is actually 3 meter, and the point, once it moves further from y1 to y2, let's say it's moving 4 meter further from here to here. So in actual, from 0, once it moving 4 meter from here to here, it was already 3 meter from here to here. So the total distance on y-axis from 0 to y2 will become 7. So if I ask you to tell me that how much change we have on y-axis from the point y1 to the point y2, you will say it's simple, it's 7 minus 3, which is 4. So it means that the change on y-axis that we have over here is 4 meter. So that is what actually change is, right? So that's how y2 minus y1, and the same goes over here in x-axis. Now one thing over here that I would really like to highlight, you really have to be careful about the index notation over here. If you are taking y2 minus y1, then you have to make sure that you are writing x2 minus x1. It would not be like if you are taking y2 minus y1 and you are writing x1 minus x2. That would be completely wrong. Okay, now I hope that you must have an understanding that how the slope is actually y2 minus y1. I have explained it with the help of a graph. So what we are going to learn today, today we are going to learn derivative of a function with the help of first principle. Now with the help, once we say with the help of first principle, it means that we are going to take a curve and there would be some point on that. Let me take now a slightly different point, because then we have to solve an example as well. Okay, let's say this is a curve that we have on an xy plane. This is your y plane, this is your x plane, x axis, y axis. Now again I am taking a point A over here, point A. Now the coordinates of this point A are, over here it's x, and over here let's say it's f of x. Now the coordinates, do not be confused in that f of x and y. F of x is actually your y. So this is your point x on x axis, and this is your point on y axis is f of x. Okay, let's take another point B over here, and the coordinate, this was your x. Now once you are moving further from left to right hand side, let's suppose that there is a change on x axis from this point to this point, but we don't know how much that change is. So what we are going to do now, we are going to represent that change with the delta x. We say that the distance from here to here is actually delta x. So the total distance from here to here, it would be x plus delta x. So once the position of x coordinate was x, your y was f of x. Now if you look at, once there is a change in x axis, it means that there is going to be change in y axis as well. Now what do I mean by that? Once there is going to be change in x axis, meaning that there would be a change in y. How? Okay, let's understand this point. Once you are moving from point A towards point B, it means that you are having some more distance on x axis, but you can clearly see the height of the curve that we are having. It means that there is a change on y axis as well. So that is why we say that whenever there is a change in x axis, there will be a change in y axis as well. So the coordinates of point B will be x plus delta x into f of x plus delta x. So these will be, so now this will be your point B. Okay, according to the, once we want to find out the, like I said, the rate of change means that the slope, rate of change means that the slope. Okay, so the slope between these 2 points will be y2 minus y1 over x2 minus x1. So what is it? It is, let's say this is your x1, x2, x1, y1, x2, y2. So it would be f of x plus delta x minus f of x over x plus delta x minus x. Now this x will cancel with this x, and we got f of x plus delta x minus f of x over delta x. You see, we have followed the definition of a slope and we got this. So it means that this is going to be the average slope. This is from point A to point B. This is going to be the average slope. Now if you see that at every instant the slope is, now over here the slope is actually tangent to the point A, now tangent which cuts the graph at one point. Now it's over here, at this point it will be over here, it will be over here, it will be over here, over here it will be. Now once you move further, it might going down. So on different points the slope is actually different. That's how we are getting a curve. That's actually the basic difference. Once we are having a straight line, in straight line it means that the slope at any 2 points that you are taking is going to be the same. Once we have curve, it means that the slope is different. Okay, now so to find out slope at a particular point, we are going to take the limit delta x approaches to 0. What does it mean by delta x approaches to 0? Delta x approaches to 0 means that this point is coming much closer to this one, so that this point will come over here. So the slope that we will have is somewhere, it's slightly like this. So limit delta x approaches to 0, f of x plus delta x minus f of x over delta x. So now this all can be written as f of prime of x. So in coming to in more, once you are studying the calculus in the higher classes, we represent this change overall as f prime of x, and this is what basically your first principle is. So if someone in your exams you are supposed to find out the derivative of a function with the help of first principle, so this is what we are going to do. Okay, now I am quite hopeful that you have the basic understanding of derivative and obviously the function as well. You know about the first principle. So let's solve one example so that you know how to commute basically a derivative of a function with respect to derivative of a function with the first principle. Okay, we can take the quick example that y is equals to 2x square plus 7. So this is the function that we have. Now, like we are finding the derivative, don't forget the graph that I made over there. So like once we are finding the derivative, it means that we are talking about slope. So slope means that we are taking 2 points on a curve. So 2 points on a curve means that there would be some change between the point. So it means that whenever there is a change in y-axis or x-axis, there is going to be a change on the other variable as well. So y plus delta y will be equals to 2 into x plus delta x square plus 7. Okay, for our simplicity, let's consider this equation as 1. Okay, now we are going to simplify this. We know that over here this is your a, this is your b. So a plus b whole square will be what? A square plus 2ab plus b square plus 7. Now we will solve this step a little further. So it would be 2x square plus 4x delta x plus 2 times delta x square plus 7, and over here we have y plus delta y. Now please keep in mind that the derivative, again I am repeating this point over and over again so that you could get to know that what exactly being going on over here. So the derivative is the rate of change in y-axis and the rate of change in x-axis as well. So we basically subtract. So what we are going to do, we will subtract equation 1 from equation 2. So in this subtraction of two equation, the left hand side of equation 2 and left hand side of equation 1 will subtract from each other. So we will write first equation 2. This is the left hand side of equation 2, y plus delta y, and this is the left hand side of equation 1 equals, this is what your right hand side of equation 2, and we will write it as it is. Just go with the flow and be confident. And then there is a subtraction sign, right? Subtract. There is equation 1. You are subtracting the right hand side. Where is your right hand side? Oh, it's over here. So 2x square plus 7. Now this y will cancel with this y and we are left with delta y over here. So it would be 2x square, I'm going fine. Okay, 4x delta x plus 2 into delta x square plus 7. Open the bracket. Once you open the bracket and you have minus outside the bracket, it means that that minus will change the sign of every single term written inside of this bracket. So it would be minus 2x minus 7. Now, you know, the beauty of math is that all the calculation are always in your hand. You can make your calculation if you want to solve your problem. Obviously you are going to make your calculation easy. So to make it easy, I will have a close look on this step and I will see that I can cancel this 2x square with this 2x square and this 7 with this 7. Okay, so we are left with let's draw a line over here just to separate it. So delta y is equals to 4x delta x plus 2 times delta x squared. Now we can see that on right hand side of the equation that we got over here, delta x is common. So we will take delta x common, 4x plus 2 times delta x. Okay, so derivative is, like I said, the slope, change in y over change in x. So we will divide on both sides with delta x, and then it would be, okay, this delta x cancel with this delta x, and we have delta y over delta x equals to 4x plus 2 times delta x. Okay, now the slope at any instant means that we are going to find the instantaneous slope. So for that we will apply the limit. Limit would be delta x approaches to 0. Like I said, that the point that we have on that graph, B is coming closer and closer to point A, which means that the distance on the x-axis is becoming smaller and smaller. That is why we take delta x approaches to 0. So we will apply limit delta x approaches to 0 on left hand side, and here on left hand side and on right hand side as well. Okay, let's remove this for little space. I hope that you have copied this example. Okay, now this will become your f of prime of x. Once you apply the limit delta x approaches to 0 on delta y over delta x, it would become f prime of x, or if the function is y, then it would become y prime. Now since delta x is approaching to 0, once you put the limit over here, it means that this value all will become 0. 0 multiplied with anything, it would be 0. Okay, so we are left with 4x only. So it means that the derivative of a function y equals to 2x squared plus 7 is 4x with the help of the first principle. So this is the basic step, this is the basic foundation of a derivative. In order to know the derivative, obviously there are many more things, the quotient rule, the product rule, and so on. So in order to know that, you must need to know about the first principle, that how do we apply first principle on any function. So I am quite sure that you have got this video. So please don't forget to subscribe and share this video as much as you can, so that it could reach to the students who are literally looking to understand the derivative of a function with the help of first principle.